Welcome back. In this video, I will explain you the Inorder Traversal algorithm in binary tree. This is a binary tree we used before during explanation of pre-order traversal. The same tree will be used here also. I will remind you the need for traversal of binary tree. The traversal algorithm ensures that each node should be visited only once and no node should be left unvisited. Now here is our algorithm. Step 1 is move to the root of the left subtree. That means you start from this root. The root of the left subtree is B because this portion is actually the left subtree and this one is a right subtree. When you visit B here, then regarding B, this one is a left subtree. So you have to move to D after visiting B. Then only the step 1 will be over and you should go to step 2 to process the node. Here are the rules you should follow while performing the traversal algorithm. Now let us move to root first. PTR is a pointer that is set to the root of this tree at A. Now you have to move to the root of the left subtree, so you should move from here to here. Now what this B is the left child of A as well as it is the root of the left subtree, right? So when you move from one node to the left child of that node, actually you are moving to the root of the left subtree. Until and unless all the left subtrees have been exhausted, you keep moving towards the left side, right? So you set top to -1 first and you increase top and push null at top 0. This will be acting as an indicator that when null will pop out of the stack, you should know that your traversal is over, just like the pre-order traversal we have discussed in the previous video. Well, you see that PTR is not null. Then what you should do? You push the current node into the stack. So increase top and push A and proceed down the left edge so that PTR is now standing at B. Again, you found that PTR is not null. So you increase top, push B inside and bring PTR to D since D is a left child of B. You find PTR not null again, so push D and bring PTR to the left edge and you find that PTR has got null because there is no left child. So you move to rule 2 where it is written PTR is null. Then you pop from the stack and process it. So D will come out, top goes down and D will be printed. In our case, processing is printing job only. After that, you set PTR to popped item. So popped item is D, so set PTR to D. So PTR comes over here. After this, you have to check whether there is a right child or not. So rule 2A and 2B describes what to do. Now see here, PTR is at D and it has right child, that is F. So we move to 2A, set PTR to the right child. So PTR will be set to F. After this, we get back to rule 1 again, that PTR is not null. Then push the current node into stack and proceed down the left edge like this. And PTR once more got null. So we move to rule 2, you pop from stack, F comes out and F is processed and top goes down to 2. And the next job, set PTR to popped item. So PTR is null now, popped item is F, so PTR will move to F. Next, you check whether there is a right child or not. This time, there is no right child. So rule B works now, right child is null. Pop from the stack and process it. So topmost element is B, so B comes out. We process the B, top goes to 1 and then set PTR to the popped item. So PTR is set to B now and standing there you check whether there is a right child or not. See this statement and check right child's presence. Now you say that there is a right child, that is E. So we move to A, right child not null. Set PTR to the right child. So PTR will be set to E. So this cycle is over. Now you go to rule 1, PTR is not null, so E should be pushed inside the stack and PTR will proceed down the left edge. PTR has got null, so we move to rule 2, pop from the stack. E comes out. E processed. Top goes down to 1 and set PTR to popped item. That means PTR will be set to A now, and then standing over there, you check whether there is a right child or not. There is no right child. So rule 2B works now. It says pop from the stack, process it. So A will be coming out of the stack. It should be processed. Top goes to 0. Then set PTR to the popped item. So PTR should be set to A now, and standing there you check right child's presence. Yes, there is right child. So we move to rule 2A. Now 2A says that set PTR to the right child. So PTR will be set to C now, and this cycle is over. PTR is not null again, so push C into the stack and PTR drops down to G. In this way you proceed and these will be printed on the screen. After this I has been processed, null will come out of the stack and it indicates that your traversal is over. You can do the rest of the steps and see whether the printing is done like this or not. In the next video, I will show you how to write code in C for Inorder Traversal in binary tree.